Today we're going to talk about Voice over LTE and how F5 products fit into the VoLTE architecture. F5 can significantly ease the pain that organizations are going to experience while using VoLTE. Large amounts of messages are going to flow through the LTE architecture in order to make phone calls. In this example, we have user 1 and user 2 who have VoLTE-enabled telephones. They're going to turn on their phones, and user 1 is going to call user 2, and then we're going to bill them for their call. In the VoLTE architecture, you have the following deployed. The EPC, the Evolved Packet Core, that allow normal telephony to occur in the mobile network. The F5 SDC, the Signaling Delivery Controller, which is our DRA, the Diameter Routing Agent. The F5 LTM, that is the Local Traffic Manager. The IMS box, IP Multimedia Subsystem, which is going to control all the SIP signaling involved in the call. Below we have the Profiles box that represents the home subscriber service containing user profiles. We have a Policies box, which is the PCRF, that is going to control all of the user policies. And finally, we have a Charging box, which represents how we're going to bill users for the calls. Okay, user 1 is remote and turns on their phone, and the cell towers send a message to the Evolved Packet Core saying, user 1 just turned on their phone, what kind of stuff can they do? Are they a good guy or a bad guy? The EPC is going to send a diameter message over the F5 SDC and ask the same thing, are they a good guy or a bad guy, and what are their policies? The SDC then is going to send a message down to the HSS, the Profiles box. Are they authentic? Are they okay to use the phone? So the HSS comes back and says, user 1 is good, the phone matches up to the profile, and they're good to go. Now the SDC sends a message down to the Policies box and says, user 1 just showed up here in this area, can they make phone calls on the LTE network? And the Policies box will come back and say, yeah, they're okay, they're good to go. Then the SDC sends a message over to the charging system and says, user 1 just turned on their phone. Have they paid their bill? Do they have enough money in their prepaid account? And the charging system will come back and say, everything checks out. User 1 is good to go. So the last thing, the SDC goes back to the EPC and says, okay, I checked out user 1. They're authentic. They can make calls, have paid their bills, and they're good to go. So user 1 is registered as far as this network is concerned. Now that user 1 is registered in the Evolved Packet Core, their phone now needs to tell the IMS network that it's turned on. So it's going to send a message down to the big IP LTM, and the LTM will figure out which IMS user 1 belongs to and forward that message over to the IMS. The IMS network needs to see if user 1 is okay, so it sends a diameter message over to the SDC basically asking, can user 1 register with me? And the SDC will go back to the HSS again and say, is it okay for user 1 to register in the IMS network? And the HSS will come back and say, yeah, they can register there. And so the SDC updates the IMS and says, user 1, good to go. The IMS network then sends back a message to the big IP LTM and says, okay, thanks for letting me know that user 1 turned on her phone. Let me know if they make any calls. And so now user 1 is properly registered in the EPC as well as the IMS networks, and the HSS knows that her phone is on and where user 1 is. User 2 is going to go through the same thing, the same signaling process as user 1 just went through by turning on their phone. This type of signaling occurs every time someone turns on his phone. The F5 value add here, we've processed 6 diameter messages and 6 SIP messages for both users. We've located profiles for all the users, session bound them to their correct policy and charging systems. We've load balanced the messages to the most available systems, and we've hidden the complexity of the networks from the EPC and the IMS cores while providing security. User 1 is now going to call user 2. So the first place that message goes is to the big IP LTM, and the LTM is going to open the message, take a look at it, and say, okay, this is user 1 calling user 2. Let me go check to see where they are. The LTM will send a message over to the SDC, and it says, how can user 1 reach user 2? So the SDC will go ask the HSS profile, where's user 2? And the HSS will come back and say, well, user 2 is on the same IMS system as user 1, and so call user 2 there. So the SDC reports that back to the LTM, and then the LTM tells the IMS, hey, you got an incoming call for user 2. The IMS system sends a message to user 2's phone to make it start ringing. User 2 answers the call and sends an answer back to the IMS. The IMS then updates the LTM. The LTM forwards that update to user 1's phone, and the call progresses. User 1 hangs up by pressing the end button. That message goes through the LTM over to the IMS. The IMS forwards that bye message over to user 2, and both sides of the call are disconnected. The IMS system is going to send a diameter message over to the SDC and say, basically, user 1 just had a billing event. And so the SDC is going to send the message to the charging system saying, here's a billing record for user 1 that contains the phone number, how long the call lasted, who they talked to. And the charging system will come back to the SDC, okay, got it, thank you. And the SDC will forward that message back to the IMS saying, acknowledged. User 2 also gets a billing record using the same methods we just described with user 1. So what value have we added here? F5 has processed at least 3 more diameter messages and 2 more SIP messages for both users. We've routed the billing event from the IMS core to the proper charging systems for both of them. So let's review what value the F5 boxes have added to the LTE network for the service provider. We've processed a lot of diameter and SIP messages for every phone out there. We've located the profiles of the subscribers and session bound them to the correct policy servers, HSS profiles, and charging systems. And we've load balanced those messages to the least busy systems. We've hidden the complexity of that network from the EPC and the IMS core, and we've provided security for both the EPC and the IMS core. To learn more, visit f5.com today.